In this presentation, we're going to look at decision theory. So we have a statistician who travels by local train to his music coaching classes, which are held for a maximum of 5 days a week. However, the classes are held at random and he is informed 1 day prior if classes are scheduled for the next day. Okay. His daily trip costs one way to his destination $50. Just a number I made up, just a round number. He's either very well paid and investing a lot into it or, Anyway, let's just accept those numbers. He needs to decide if he wishes to purchase a weekly train pass, which will cost him $320. Okay. The probability of the number of times coaching classes are held in a week are as follows. We'll come back to that shortly when we talk about the Bayesian criterion. Okay. Given that he never misses a scheduled class and travels by train only, find out his Minimax and Bayes criterion decisions for what he's going to do with regard to purchasing tickets. Okay, so the Minimax, the costs incurred by the student attending coaching classes depended on the number of classes. Okay, so essentially the most per class he will spend $100. So it's $50 out, $50 back. Okay. So if he has a full week of classes, all 5 days have classes, and he travels by train every day, and a one-way ticket costs $50, that means he's going to spend as much as $500. Okay. Now, if he purchased the train ticket or the weekly train pass, he will only spend $320. So he's got two decisions. D1, decision of not buying the weekly pass, or D2, buying the weekly pass. Now, just to be clear, he doesn't know in advance if it's going to be 1 class, 2 classes, 3 classes, 4 classes, or 5 classes. Okay? So when he's buying the ticket, or he's making this decision whether or not to buy the ticket, the weekly ticket, he doesn't know if it's going to pay off for him or not. Okay? Because if there's only 3 classes, he's losing $20. Okay? But if there's 4 or 5 classes, it was a good decision. Okay? So the maximum cost under the decision D1 of not purchasing weekly train pass is $500. Okay, that is the most he can lose, or most he can spend. The maximum cost under decision D2 of purchasing the weekly ticket is $320. Okay, so the Minimax is the minimum of those two maximum outcomes. Okay, and obviously the Minimax is the minimum of the costs, maximum cost. So therefore D2. Buy the ticket, buy the weekly pass. Okay. So, under the Minimax, the student should buy the weekly train pass. Okay. Now, the Bayes criterion allows us to incorporate these probabilities. Okay. So, it's the expected cost of the train tickets based on these probabilities. So it's the expected value of a discrete random variable. Okay, so there's 20% chance that he only has to buy one ticket, one pair of tickets. Okay, there is a 10% chance that he only has to buy tickets for 2 days, which there's a 30% chance that he has to buy tickets for 3 days. There is a 25% chance that he has to buy tickets for 4 days. And finally, a 15% chance that he has to buy tickets for 5 days. Okay? So, essentially, these are the costs here. And these are the associated probabilities of those costs. So it's an expected value of discrete random variable. You work it out and it turns into $305, which is less than purchasing the pass, the weekly train pass. So under the Bayes criterion, not purchasing a weekly train pass is the decision which minimizes the expected cost and hence is the Bayes solution to this problem. So that's it. We'll leave it there.